Hi, and welcome to another lesson, 5.6, Proving Triangle Congruence by Angle Side Angle and Angle Angle Side. So we're going to start off first with a construction, okay? Now on page 148, please make sure you glue a half sheet of paper. Write down the title, Construction, Copying a Triangle by Angle Side Angle, and draw a line right through the middle so you have enough space to do the construction. Now that's on page 148. On page 149, you are going to glue another piece of paper, another half sheet of paper. And what we're going to be doing in here is we're going to do a very, very quick proof to the angle side congruence theorem. It's going to be super simple and small. So just draw yourself a small 2-column proof and be ready for that. Now on page 150, please make sure you write down the problem numbers. Now, I'm putting them in this order specifically because the examples go with that theorem. So up here, problem number 1, down here, problem number 2, and right here, problem number 3. And I believe there's only 3 examples for this lesson. Okay, so 1, 2, 3. All right, let's go back to page 148 and start our construction. So on page 148, what I want you to do is I want you to construct yourself just a triangle. Make sure your triangle has all 3 sides that are different to the best of your abilities. Okay, we're going to call this triangle A, B, and C. And what we're going to do is we are going to copy this side here along with this angle right there and this angle right here. Okay, so that's what we're going to do. So the first thing we're going to do is we are going to copy segment AB. Okay, so in order to copy segment AB, sorry, my camera's moving a lot. Trying to get some space in here. Okay, for segment AB, you're going to draw yourself a line that is visually bigger than AB. Just bigger. Just like that. Pick a point, call that A prime. Now what we're going to do is we are going to copy segment AB first. Okay, so copy the segment by measuring from A to B, just like this. A little more from A to B, just like this. Put it on A prime and draw yourself a little arc. Once you do that, that's going to be your B prime. So what I just copied right now was segment AB into A prime B prime. So the next construction, or the next part of the construction, is we're going to copy both angle A and angle B. So in order to do that, we're going to use the same size arc. Okay, so open up your arc to really any measurement. And I want you to just make sure the measurement is less than the distance of AC and BC. So from here, you are going to make an arc such that it intersects both of the sides like this. Do that and then do it again over here on B prime. Make sure your arc's a little bit bigger than that one. Do the same thing for A and A prime. Okay, so move that out of the way. So do that for A and A prime. Now, here's the next part. What we're going to do is we are going to measure how open this arc is right here. So I'm going to measure from here to here, like this, from here to here. And I'm going to copy it over here. Boom, just like this. Then I'm going to do the same thing for this one. This is like measuring how open the alligator's mouth is. Don't ever do that, by the way. Okay, from here, you do that up to here. So here's what we have now. Now what we're going to do is we are going to from A prime to that point of intersection, you're going to draw a line. Doesn't matter really how big. Because what we just did right there is we just copied that angle, which is this one right here. This one and this one. We just copied it. Now I'm going to do the same thing for the other one from B prime to that intersection. And you do it until you hit the other line. So what I just did right now is I just copied this angle right here. And of course they're going to intersect at C prime. So what we just did is we just made angle A congruent to angle A prime. We also did segment AB congruent to segment A prime, B prime. And we did angle B congruent to angle B prime. So what we have is two pairs of angles. Okay, two pairs of congruent angles and one included side. Okay, so what am I talking about here? You see how you have these two angles right here? The side containing those two angles is called an included side. So this side right here is called an included side. Up here, this is also the included side. Now, if I were to do, and by the way, this segment and this segment, they're both congruent. If I were to measure this angle and this angle, of course, it will be the same. Also, by the third angle theorem, they'd be the same. If I were to measure these sides, they'll be the same. So guys, these are going to be congruent. So this brings us to the angle, side angle congruence theorem that requires two pairs of congruent angles and one included side that is also congruent. So here's my other tool. Okay, so far you've had quite a bit of tools: side, 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 side angle, side. And now we have angle, side, angle, and I'm going to show you guys angle, angle, side in just a second. So the angle, side, angle congruence theorem tells you that if two triangles have two pairs of congruent angles and an included side, included just means that it's the segment that includes both of those angles. You can see this side is included in this angle and this angle. Therefore, the two triangles are going to be congruent. So let's look at the next page now, and let's talk about the angle, angle, side congruence theorem. So in the angle, angle, side congruence theorem, what you have is if you have two triangles, call them A, B, C, D, E, and F. If you have two pairs of angles that are congruent. For example, here's one pair, here's two pairs, and then you have what you call a non-included side. So for example, this side would be included because it includes these two. So this side is not included, not included. So I would have this one and this one. Okay, so once again, you have two pairs of congruent angles and one pair of non-included congruent sides. Therefore, these two triangles would be congruent, and let's prove why that's so. So ABC would be congruent to triangle DEF. So why is that? Well, let's prove that. Okay, so let's start first with what is it that I am given and what I'm trying to prove. What's given to me here is that angle A is congruent to angle D. Angle B is congruent to angle E. and also BC congruent to EF. And what I'm trying to prove here is that the triangles are congruent. Okay, so that's what I'm trying to prove here. Now, to prove this, it's extremely easy to do, because think about this. You have two pairs of angles that are congruent. By the third angle theorem, well, so is going to be the third pair. So in this case, you would have, you would have the third pair also be congruent. And therefore, by angle, side angle, the triangles are congruent. So let's start. Okay, what is given? Angle A is congruent to angle D. Angle B is congruent to angle E. And BC is congruent to EF. All of this, it's given. So now the next thing is that angle C is going to be congruent to angle F. Why? Because of the third angle theorem. If you don't remember that, look it up. Therefore, the two triangles ABC congruent to DEF are going to be congruent because of the angle side angle congruence theorem. Okay, let's move on to the next page. So once again, here are the two theorems. The angle side angle congruence theorem requires two pairs of angles congruent and an included side congruent, therefore they're congruent. And the angle side congruence theorem, which requires two pairs of angles congruent and a non-included side. So here's that's pretty much the difference. Here it's included, here it's not included. Sorry. So let's go ahead and start with the examples. All right. So here is the examples for example number 1. I know it's a little hard to see. Let me zoom in a little bit more. Okay, according to this, the only thing that you have here, according to this, is you have one pair of sides here, one pair of sides there. Let me redraw this because I know it's a little hard to see it. Gives you something like this. You have this pair of angles that is given and this pair of sides that is given. So what you have given, according to this, is you have one angle and one side that are congruent. That's not enough because that only gives you an angle and a side. So you need something else. So if you look at this, these here are vertical angles. So this angle here is congruent to this one right here. So therefore, you have another angle that is congruent. So therefore, now I know it says ASA, but if you think about it, you have two pairs of angles congruent and a non-included side. This one here is not included. So therefore, these two triangles are congruent by angle, side. On this one, they don't tell you anything about any side being congruent. So the only thing that you have is 3 pairs of congruent angles. That's not enough. You don't have an angle congruence theorem. So not congruent. Okay. Now on this one, I know it's a little hard to see, so let me redraw the diagram. Okay, man, that don't even look like that. Okay, so here you have this one, this one, this one, and this one congruent. So all they give you is 2 angles, 2 pairs of angles. But keep in mind, this side is congruent to itself. So not only do you have a pair of angles, you have a pair of sides and a pair of angles. So angle, side, angle, angle, side, angle. Therefore, the two triangles are going to be congruent. Okay, so that is example number 1. Let's look at the next one. The next one is a proof. All right, what you have here is this side and this side, they're parallel. AD and EC are parallel. BD and BC are also congruent, and that's all they give you. And they want you to show that these two are congruent. And guys, there's more than one way of doing this. Okay, so what I'm going to do is I'm going to use vertical angles. Now, this angle here is going to be congruent to that angle right there by vertical angles. I deducted that. So just with this, I only have a pair of angles and a pair of sides. So I need another pair of angles. And there's more than one way of doing this. So I am going to pick this angle here to be congruent to this angle here. And why is that? Because you have a set of parallel lines cut by a transversal. This angle and this angle are alternate interior angles. Therefore, now you have angle, side, angle. Angle, side, angle. Okay, so I have enough to do my proof now. Step 1. AD parallel to EC. And BD congruent to BC. That is given, and that's going to count as one of my sides. Now, what I deducted was the vertical angle. So I have angle A BD congruent to angle EBC. ABD, EBC. Why? Because they are vertical angles. That's my other angle. Now, I now have angle D and angle C congruent. Why? Because of the alternate interior angle theorem. So now I have another side. So what I have here is I have angle, side, angle. Oh, not side, sorry. Angle. Okay, so I know these are out of order. That's okay. I can see those. Okay, I know they're out of order, but that's okay. Therefore, I do have angle, side, angle, angle, side, angle. So therefore, triangle ABD is going to be congruent to triangle EBC by the angle, side, angle congruence theorem. Is this the only way? No, there is also an alternative way. You could have done angles A and E instead of C and D. If you were to do that, then instead of angle, side, angle, you would have gone angle, angle, side. So the methods are different, the approach is different, but the result is the same. You're still proving that they're congruent. So that was example number 2. Let's look at example 3. Okay, so in this example, it says write a proof, and they tell you that HF and GK are congruent. Okay, so what you have here is that F and K are congruent and they're right angles. So I mean, first they're right angles, therefore they're congruent. These are parallel, therefore this angle here is going to be congruent to this angle right there. HG is going to be congruent to GH by the reflexive property of congruence, and therefore you are going to have angle, angle, side. Angle, angle, side. So that's going to be the reason why they're going to be congruent. All right, step 1. HF parallel to GK, and angle F and angle K are right angles. That is given. Now, here's the thing. Because they are right angles, we know they're going to be congruent. So angle F is congruent to angle K. Why? There's I can't remember the name of the theorem, but I know that is all, I think it's a right angles theorem. Okay, all right angles are congruent. Now, these two angles are going to be congruent, and yes, you do have to use the 3 letters. So angle FHG is going to be congruent to angle KGH. Okay, why? Because they're alternate interior angles. Alternate interior angle theorem. Okay, so far here you have an angle, you have another angle, and now you need another side. So here HG is going to be congruent to GH. Why? Because of the reflexive property of congruence. So there's your other side. So now these two triangles are going to be congruent by angle, angle, side. So angle, angle, side. How do I know that? Because the side is not included. Okay, and this is going to be by angle, angle, side congruence theorem. All right, and that was example number 3. Please make sure you work on the extra practice, and I will see you all later.